Okay, so this is a different kind of problem that I want to show you here. So let's go ahead and read the question on your own, and you can pause the video, read the question, and then you can come back to the video a moment later. So let's go ahead and approach this problem. So we have a snowball, so it's going to be a sphere. Okay, let's go ahead and draw a sphere. The surface area decreases at a rate of 0.5 centimeters square per minute. So we have dA in dt, it's equal to 0.5 centimeters square per minute. Okay, and then we have how fast is the diameter. Now we have something different right here. We have something called diameter. Okay, it's not radius. So how fast is the diameter decreasing when the diameter is 10 meters? So we are given diameter is equal to 10 centimeters. Okay. Now let's go ahead and get the equation for the volume, the surface area of a sphere. So the surface area of a sphere is going to be 4 pi r squared. Now, I don't know if you realize this. We have radius here, but the question is talking about diameter. So we have d here, we have r here. They are not really the same thing. So what do we do? Well, if we don't see the diameter, let's make diameter appear in the equation. So how can we do that? Well, let's ask ourselves, what is the diameter? And diameter, it's essentially 2 radius, right? So that means we can rewrite this equation as 4 pi and r is equal to d over 2. So d over 2 square. Okay, let's simplify this equation. So we have a pi and the 4 pi d squared over 4, and 4 here, they cancel each other out. So a simplified equation is simply pi and d squared. And again, pi here is just a number. Okay, it's not a variable, it's just a number. 3.14 blah blah blah. Okay, so I don't really care about the chain of decimals here, just knowing that it is a number. Okay, now we are curious about the change of diameter. Okay, and oh, by the way, this is 0.5 centimeters per minute, and it is decreasing, so it's very important that you put a negative up front. So we are very curious in finding out what is the d over dt of d itself. Maybe I should not use d to, that's kind of confusing, but well, so if that's confusing, let's go ahead and change this to x. Okay, let's go ahead and say d dx dt. Okay, let me do it this way, dx dt. And let's say we have x here, this is x, this is x, x, x. So let me go ahead and rewrite this equation, pi x squared. Less confusing. Okay, so we will go ahead and differentiate this. So we will differentiate this equation in respect to time. So we have d over dt, pi d over dt of pi x squared. Pi is just a number, we can move it up front, and so we actually have this equation, d over dt of a, pi, and d over dt x squared. All right, so now what we have here is that a is changing. Okay, the surface area is changing, but this is not t. Okay, it is not a variable t, but it is actually a function in terms of t. So, and so as the diameter x. So we will say the area and x, they are both functions of t. Okay, they change as time changes. So we will need to apply chain rule, and since we don't see t right here, we called it implicit differentiation. So we differentiate a, so a becomes just 1, but this is a function itself. We use chain rule, we multiply the derivative of the function itself. Pi, and we will differentiate to x squared, so we have 2x, but x itself is a function, so it becomes dx dt. Okay, so now what do we have here? We have dA dt, which is negative 0.5. So we're going to put in negative 0.5 right here, put in pi right here. Do we know x? Yes, x is given. X is 10. Okay, and we will go ahead and solve for dx dt. So if you put everything into calculator, so you will have, let me see, you will have dx dt, it's equal to negative 0.00796. Okay, and this will be in centimeters per minute. Now, does it make sense to have a negative number? I would say it makes a lot of sense, because as the whole snowball melts, the surface area is going to shrink, so as the diameter, and that is the reason why it is very important to label this number right here with a negative sign, and that would guarantee us that we will have a negative sign for our change in diameter. Okay, all right.